Good morning, everyone. It's 5 o'clock in the morning, and I couldn't sleep, and my mind just won't stop working. So I decided to do something meaningful instead of just try to sleep. And yeah, here I am. Let's talk about snow. Okay, let's begin. First things first. Let's crack. Dive in. Don't want the shader. And sorry, put a box here. Maybe this big, I'm not sure. So copy the size, paste to the center, and divide by 2. Sorry, divide by 2. It depends on how high you want. Let's check the animation here. It's not enough. Maybe put it to 300. Yes, somewhere like this. Let's make it bigger. Then let's check this out. We can give it more space. Okay, and then time shift. Later we're gonna use Vellum configure grain to convert this. Sorry, into particles. See, into particles. But now, for now, our character, which is correct, is already stand there. We need to get rid of what's inside the body. Yeah, you know, there are something inside the feet. So this dots, so we gotta delete it, get rid of it. You can put a group here. Sorry, I haven't freeze it. You can put it here and make it a point to this and blast it. Yeah, you can do that. Or I guess you can do one. I guess you can do boolean first, and oh, sorry, we need to for that we need to convert this guy. So, and then we connect here. Yeah, it's almost the same, I think. Doesn't matter which way you wanna choose. Okay, and next thing, there is a oh, sorry, I forgot to mention. The reason I decided to use Vellum grain is because the Vellum system is very happy to accept all kinds of constraints. We got all kinds of Vellum glue constraints, right? For example, this guy, we can choose. Maybe we can choose. Glue. For example, I want you to search maybe 4 points, and let me check. Yeah, gonna be 4 points to points. See, these are all connected by the Vellum solver. Okay. Yeah, that's the reason why I choose to use Vellum. Yeah, the most important thing is to me is Vellum is constraint. Why am I saying this? Because you can also use pop grain. Yeah, this is the other way of doing this. You know, Vellum, if I remember correctly, Vellum was built, I guess, for Houdini version 17. Before, there wasn't Vellum system, so people use this one instead. Yeah, it's almost the same, but I don't think this will accept or recognize any kind of constraint network. I didn't test it, but I don't think. Yeah, maybe I can test it later, but for now I just try to use Vellum. Okay, let's head back. Okay, I don't think we need this anymore. It doesn't matter which one we want to use. We can do that and blast out this. Maybe call this inside. This inside group and yeah, paste here. Okay, something like this. Good. And the next thing is still I think I'm gonna need it if I'm going to do this. This is our correct, and this is a lab tool. You just type snow here, and it's pretty convenient. Yeah, give it some time to think. Okay, you can change the color so you guys can see better. Yes, I guess this is pretty convenient. For example, if you have a if you guys have a stone or something, and yeah, something like that. If you connect it here, you will easily get your snow. Come on, think about it. Come on. Okay, but to me, why I want to do this? I want we can put it here and convert it. Doesn't matter. We can do that. Sorry. And I think we can put this guy into a group. I try to do that inside, I guess. If you want, let me check. There's a keyboard original. We can delete it, and we cannot see anything because this is not watertight anymore. We can go in, and I guess is somewhere around here. The boolean. Yeah. Oh, anyway, you can just figure it out. It's not hard, and then it's gonna be watertight. Then you can use this point. For me, I'm lazy, and I just come back. Let me put it here. Here. This is mesh number 1. Let's merge. Yeah, this is mesh number 2. Oh my god! I think I still need to go in. Okay, let's now go to lazy people. Let me check where is it. Yeah, before it was okay, and this is the boolean, and see this is still watertight, I guess. And the blast here. They used a blast node to blast the inside. We just keep it, and that's it. Let's check. Okay. So we got our snow. Yeah, for the first frame. Why do I want to use that? What is this? I don't remember. Okay, the next part is about constraints. Right now we do have some constraints, but this is how do I describe this? Right now what we have, these little dots, they are constraints, but they stand for PVD. It's all about the particle size, so the Vellum system know how the points collide to each other. This is PVD, okay? Sorry, PVD. And PVD stands for point-based dynamic. So that's the whole point of PVD. It's very different from POP, because POP never care about the radius, but PVD does. And this is only for radius. I don't know how to describe this. I hope you can understand it. and see this diameter of the particles. Okay, but what we want is actually more than this. Okay, for example, I will demonstrate. Yeah, less particles so we can be more efficient. So if we're gonna do Vellum solver, and we can give a ground plane. Yes, check this out. See, everybody collides with each other. Yeah, it's gonna be crazy. Doesn't matter. I just want to show you. It's actually we can make our own constraints, make our own point of op, and it one noise. Yeah, one noise. Put it here. And what we want is actually the seed. Let's put a random here, but maybe later. Before that, let's bind out the result. Say, call this cluster. I like to use the cluster, and I give it a random, maybe 3 color. So you can see these are different clusters. Yeah, it works. Maybe only the frequency. We want something like maybe something like this. It depends on what you need. We can add another more noise. Put it here, and we can actually add them together. Sorry, it should come from the seed. Can you see the pattern moving? There's a different pattern. Maybe I can put lower. I'm not sure. Yeah, let's leave it here. And the reason, let me call this cluster. Why I want to do this is because we can put wrangle. Oh, sorry, houdini crashed. Let's put a point wrangle here. We want random, get a random number based on the different cluster. I'm gonna say if this guy is greater than, I call this keep maybe, or blast, doesn't matter. If this number fits this condition, then we're gonna remove the current number. Right now it's all gone because there's no threshold. You can see we get this kind of gaps everywhere. Okay, we can furthermore control it, but I'm not gonna do it now. And for that, let's say how do I call this? Blast. Yeah, make gaps, maybe. And what we actually want is our good friend connect adjacent pieces. Connect adjacent pieces and connect. Oh, that's too much, I guess. I'm not sure. Are we gonna use the rest length? But just leave it there. I want different cluster to separate from each other. I want if you can check the different colors, this color and this color, they are different, right? But they are connecting to each other, which means the different clusters, they are connecting. I want to break it. Since first let's make our make a primitive wrangle, which means this is gonna run over each primitive. For example, this one. Let's delete it out and use that. Come on, man. Where are you? Here you are. Let's check the different clusters right now. This primitive have 2 points, 0, 1, and 1, right? So on point 0, this is the cluster number. For 1, this is the cluster number, which means if we're gonna run over this primitive group, array, and then I'm gonna bring points to run over. I keep forgetting how to use this. And geometry number and current primitive number. We got our points, okay? And then we got points, and then we can get a different cluster. Maybe say this one, cluster 0 it comes from the first points, which is PTS 0 here. And this one is 1 because it only has 2 points. Let's prove to ourselves. We got cluster 1, cluster 0 and 1, right? And we're gonna compare it. So if this guy, cluster 0, cluster 0 not equal to cluster 1, then you're gonna remove the current primitive. Okay, number. Let's go. See, it's gone. And let's disable this guy. Wow, what do we have? What do we have now? We don't have anything. Let's check. Sorry, I misspelled that. Cluster 1. And let's get rid of the points. Yes. This is what we get. It's all disconnected. Alright. Let's delete this one. Merge them together. This is what we get. 2 kinds of clusters. I'm sorry, I made 2 mistakes. Yeah, the first one is about the snow build. Right now, the crack is moving, so it has to compute every frame. That is not what we want. You can see it's computing, but it only needs to from the first frame. It should be static. I mean, the crack never moves. And mistake number 2 is I shouldn't do this because if we try to blast out the points, this is not what we had before, right? We lose some particles. We have to merge them back after we did our little connection thing. Let's try to fix this. Attribute keep equals random. Random cluster. The point is that we got our keep. Why don't we use split? I'm gonna say, your points. If keep is greater than, give me a float. Let's call this one keep and keep, and copy this guy. Put it here. We can do the same thing. We can still blast out what we want, right? Connection. Yeah, blast zone connection. We can still merge them back. Yeah, that's pretty different. We're not gonna lose what's left. Okay. After this, we can give it a Vellum glue constraint. Where is glue? Vellum glue constraint. Let's check this. The reason why we're gonna use this is because this one can generate some attributes We don't have to manually create them. Okay, let's see what we get. We get our dots. What we need is the greens, the dots. But right now we have the lines. But we're now here to compute the lines, right? So why don't we just get rid of it and check this out? We got this much number of points, 37, and before 37, right? So the numbers are equal, right? But let's check out the constraints. The constraints is weird. It's different from what we had, right? So we need to connect them in this way. These are all okay. All right. We can delete this. We can delete this. Go back and put a Vellum solver. Start to solve it. For that, we're gonna need our correct way here, yeah, buddy. And of course, a ground. Okay, our first simulation. Let's check. Okay, it's gonna be like this, something like this. For this, I think we need more sub-steps when things comes to Vellum. Most of the time, you're gonna need sub-steps. I'm not sure, but you have to crank it up. And next part, I want to give you make it more static, I guess. I'm not sure, but we can try. Maybe give it a little damping. Oh yeah. For this guy, I want to give you another attribute, which is you can break the break threshold. Let's leave it here, which is this 1.1. Negative one means never break. It doesn't matter. Let's give it a try. Okay, guys, this is what I cashed out. Yeah, this is this is not what we did just a moment ago. The cache is really time consuming, so I'm just gonna use what I tested before, the last version, the previous version, to show you what's going on back then. And anyway, this is what I cashed out. But for this one, I add a stop here. First, I put everything into sleep, and then I add a pop awaken to awaken only nearby the crack, okay, the particle which is nearby crack, and it helps. It saves us lots of time. And there's another way which is not using that, which means we can put everything, this one, put everything but the edges. I guess is here. Let me demonstrate. We can make something like this and put them into a group. Wow, it's really laggy. You can see that too much particles. And inverter, so we get the edge of this square, okay, and put them into sleep, meaning set the stop attribute to be 1. So the edges, these 4 edges, they never move. So the advantage of doing this is if your composer, they asked for a hard edge for a mask or something, you can easily do that. Okay. Anyway, either way, that's that. I got this. I lost the sprite, and then I add the sprite myself. By the way, if you're wondering how to get the sprite back, you just add a sprite swap and choose texture and up level. You can see there is a yeah, there's a sphere map, just this guy, just this picture, and then it's back. After that, I said give it a density, which is which is 1, so everyone's equal. And then the another really heavy one is pop replicate. I cannot choose this one, and I cannot see the result because it's gonna kill me. I use the pop replicate to replicate 20 times for each particle. So that's what we have. This much particle multiplied 20. It's really gonna be huge. But if we do that, and the the volume's gonna be bigger. So we have to find a way to how to say this, how to put this. So we have to find a way to shrink each particle so it can fit. To be honest, I find out this method from Stephen Yiping. Yeah, he's got a great tutorial about Snow, about how to compute the p scale. I should say address, and you can check out if you want. Anyway, this is his method, and it's really brilliant. And after we set the p scale, then we can rasterize it and use velocity motion blur. And this way, when the particle flying, there will be trails. So we don't have to render motion blur. Okay, it's already baked in here. And for me myself, I then compute the gradients from the density. This is only the density. Anyway, I got the gradient, which is like a normal thing for VDB, and I can give it to render. So the shader, the render, will recognize it. It will render out the reflection. So the problem is the gradient is actually negative. So we have to manually negate it, which means multiply by -1. Don't forget put V here, otherwise it won't be right. And we merge them back. Now we should have the density and gradient. Okay, then we just I think maybe I can demonstrate this. Yeah, the VDB cache is smaller. You can see we got a density and a gradient, this flow, this vector. And then this is our snow, this is our correct, and I just fetch them back into stage, which is lop. This is a snow, this is body, and I made 2 different. Yeah, you can forget about this. This is nothing. Yeah, I just use a basic white word to render out the VDB because this guy actually recognizes a gradient. You can see it's already there. Yeah, we can copy it ourselves to maybe copy it to a Pyro solver and assign it to the snow. And yeah, this is the snow from correct shoulder. Doesn't matter. I guess this is correct. Yes, that's correct. And then I made a ground, add a light, and then I used karma. I try to use karma these days. I try to figure out how can I use it better. Yeah, I guess still a long way to go. So much to learn. Okay, that's it for today. I think I have to sleep. Like always, I hope you find this video useful, and I will see you next time.